Okay, I'm glad to see we've already got questions. Awesome. I will wait for a few more people to sign in and ask questions, and get started in just a moment. Okay, so something I wanted to start with is to talk for a moment just about the structure of the code you ought to be writing. So yes, this project is about writing a KNN learner, but you should follow the example of the linreg learner that we provide you. I just want to step through each of those methods real quick, and then I'll turn to the questions that you all are asking. Okay, so you should be seeing, yes, you are seeing my text. So this is my implementation of the linreg learner. Notice we're taking in this argument verbose, and that's something you should take advantage of. Essentially, if verbose is true, that means you should feel free to print as much as you want for debug statements. If verbose is false, don't print anything. And when we're testing your code, verbose is always going to be false. Okay, so that's the constructor. One thing that we should have done here is to record verbose. We should have a instance variable called verbose and just set it equal to that. So self.verbose equals verbose to save it. Okay, add evidence. This is obviously one of the most important methods in the learner that you're writing. And let's look at the arguments real quick. So data X, that is a ND array of as it may have as many dimensions as we like. Each row represents one sample of data, and each row in data X corresponds to a row in data Y, and together they're one sample. So we might have, say, 4 columns versus 1,000 rows, and that would mean that we've got a 4-dimensional X. We always are assuming 1-dimensional Y, though. So keep that in mind. Y is always just 1 dimension, but our X values can be multi-dimensional. Now, the purpose of add evidence is to take that data and build a model from it. And as you can tell from the name add, it was intended that you could call it multiple times and add more data as you go along. It turns out that for this project, add evidence is only called once. So in this case, for linear regression, we don't save our data here. We just build a model and return. But it would make perfect sense, for instance, for KNN, to save the data, and then if add evidence is called again later, you could just append that new data to the end. Let's look real quick at how linear regression works. So we have our X data, and what we do is we build a ND array using ones, so it's going to fill it totally with ones, but we build it in terms of dimensions, essentially the same size as our X, but we add one column here, and that's what this +1 is. So recognize here, now that we've got a ND array, same dimensions as our incoming data, but one more column added, and it's completely filled with ones. Then we add also after that, I'm sorry, we also then insert our data X into the other columns. So we've got multiple columns of the original data plus a new column of ones. Now, what's that new column of ones about? That's a trick for linear regression to cause the linear regressor to find your constant coefficient. I guess don't worry too much about that, but that if you're ever using linear regression and you're using, say, this linalg module, be sure to add an extra column of ones. Anyways, all we do is we call linear regression with our X data and our Y data, and then it returns a number of results. The only ones we're concerned about are our model coefficients. And then the model is done. So we save these coefficients into instance variable, and we're done building the model. Now when we're queried, all we have to do is, so we've got the X variables that are coming in. We need to compute the Y's. We just plug them into the equation using the coefficients that we've got, and boom, out comes the result. Okay, so the reason I went through this, talking about linreg learner, is this is the same structure you should use for your KNN learner. Okay, I see we've got a bunch of questions, so I'm going to step through those questions, and we'll just see how the conversation carries us. Okay. I'm going to select questions now. Okay, our first question. I'm interested in how we are to graph this data for our report. My understanding is that we have 3 points to graph. So if it depends on which graph, but sort of the canonical way to evaluate how good a learner is working is you create a graph where the x-axis represents the actual value, and the vertical or y-axis represents the value that your learner returned. Now remember, our model just returns a single dimension that we're calling y. So you can create this plot no matter how many dimensions you have in x. You can create this plot with just a two-dimensional graph. So you're plotting what the actual number is versus what your model thinks it is. And if that scatter plot is a straight line, then your model is working perfectly. So to the extent that it's not a straight line, that indicates that your that your learned model is not as accurate as it could be. So, anyways, to answer your question, you should make a two-dimensional graph reporting the quality of your learner. Okay, next question. So this question is about the bag learner. Should the sampling of the bags be done in the add evidence level or every time we have a query? Okay, so the answer is the sampling is done at the add evidence time. So when you call your bag learner with X and Y, so it's just like add evidence for for the linreg learner. So you're past training X and training Y, essentially. It's within this method that you should create the bags. So you sample with replacement from data X and data Y. You need to make sure that you preserve the X's and Y's, as individual samples. And then you just make a for loop, sample your data points, and then train your learners one after the other. So anyways, the answer is you do it at the add evidence level. Not seeing anything. Has it started? Okay, I hope that you're seeing something now. If you're not seeing something, let me know. For KNN, should have implement pre-processing of data. For this project, no, there's no pre-processing of data. For the next project, we're looking for you to generate some technical indicators that you're going to use to train your KNN model. Yes, and for that next project, you probably do need to do some normalization of the data. I know for this project, Y is always one-dimensional. Is there any learner that can handle multidimensional Y? Sure. In fact, it is trivial to extend this learner to multidimensional Y. One way to do it is create a learner for each dimension. So you split your Y into multiple columns, and you train your first learner to learn the first dimension, you train your second learner to learn the next dimension, and so on. You can also do that internally to your learner, so that externally it seems just like it's directly learning those multi-dimensional Ys. The reason we're just using a single dimension Y to learn is that for most applications, that's what people are looking for. And in fact, in our case, so imagine it's a classification learner. That's essentially, one dimension. You're just classifying it into one of multiple classifications. In the case of regression, predicting a future stock price, again, that fits nicely into a one-dimensional Y. But anyways, it's not hard at all to make it multidimensional. I'll take the next question now. I'm finding for the KNN analysis of ripples that performance of the test and train performance are pretty similar. Does that sound right? If so, how should we write this up? Just indicate the K values where train outperforms tests. So I think for all of the data that we provide, you should get similar performance for in-sample and out-of-sample. Obviously, in-sample should be as good as or a little bit better than out-of-sample. But one thing to point out for some of these data sets is that there is no noise. So for that reason, I would expect that in sample and out of sample are pretty similar. Anyways, in terms of how to write it up, well, just observe that that you're getting similar results. But I expect that what you're seeing will change as you use different K values. Very simple question for part 1. After creating the KNN learner class, should I update test learner to call the KNN learner class? So first of all, you don't turn in test learner. That's just example code for you to use to test the code that you create. So yes, you should test your learner class by plugging it into test learner. And that's actually where you should get most of your results, is by adjusting test learner as necessary to query your, to test your learner. Anyways, to answer your question directly, yes, you should update test learner to call the KNN learner class. But remember, you don't turn in test learner. In the bag learner, can you explain what we are using the KNN learner for, since it is passed into the method learner equals KNN learner? Okay, let me switch my screen to show you the API that we're looking at for bag learner, and then I'll be able to answer that a little bit better. So give me a moment to call that up. Give me just a moment here. Okay, I got to use a different browser. Sorry about that. Just bear with me. Okay. I'm sorry for this delay. Okay, I'm going to show that other screen. Just one second. Okay, so this is that project, and I'm going to scroll down to the API for bag learner. Okay, so it's pretty simple, but I called it up because I want to go over this constructor. Okay, so we're creating a bag learner. We're going to have 20 bags. So that means we're going to have actually create 20 learners within this bag learner. The learners that we're going to compose it of are KNN learners. Now, note that you should be able to pass the bag learner any sort of learner. So you should be able to pass it linreg. You could create a decision tree learner. In fact, if you created a decision tree learner and then you created multiple bags, you've essentially created a random forest. You can create it trivially with this bag learner once you've got it written. There is also this. It's called KW-args or keyword args. And these are the arguments that you want to pass to the learner when it's created. So in this case, we're going to create 20 copies of KNN learner. And for each copy, we're going to pass along these arguments. So KNN learner will get to know how many, what K it should use. Let's look at these other factors or these other arguments. Boost. So if you're going to implement boosting for extra credit, you pass along boost as true. Well, when you do your testing with boost. And then, of course, that verbose flag that we were talking about. And then add evidence and query are the same. Now, I want to show you real quick. If you look down toward the bottom, we have a hint about how to instantiate multiple learners. So we start with an empty list. We remember we had passed in these KW-args, but right here, just as an example, I'm setting it to be equal to that. Anyways, for I in range of the number of bags we have, we create a learner, and we create it with the KW-args, and boom, that creates a list of these learners that we're creating. Okay, let me go back to the original question, make sure that I answered it. Okay, can you explain what we're using the KNN learner for, since it is passed into the method? So anyways, the bag learner needs to know which learner it's adding to the bags. So that's why you have to pass KNN learner to it. And like I said before, you can pass different learners to it to create bags of different learners. I hope that answers your question. If not, ask again. Okay, we know the third column in the created NumPy array for the spatial data is Y. Do we really to separate X and Y for the KNN learner? Seems easier not to split it out so that we can easily look up the actual Y once we find min distance. So it is often the case that as an API to learners, they add on the last column as the Y value, and they just pass a single NumPy array where the first, let's say we had 2 dimensions of X and 1 dimension for Y, they would have a 3-column NumPy array where the first 2 represent the X's and the last one is the Y. That is fairly common. In this case, the API that we define here separates them out, and just because we've structured our grader that way and so on, you need to submit it that way. But yes, I could agree with if you were implementing this from scratch, you might pass it as one single array. Can you review the Ada Boost algorithm? Um, uh, good question. Let me, actually, I think that I describe it in one of my lectures in the class. Um, it uh, it it takes me a few moments to prepare to present that one. Let me refer you to the videos I've already recorded for the class. But at a high level, I'll describe it as follows. Um, the the general idea is that as you create bags for your learner, each new bag that you add uh, should selectively choose samples from the data, from the training data, that it was not well trained on earlier. So let me sort of step through that. Um, you train the first bag of your bagged learner uh, as usual. You select with replacement in samples from your train data. Um, but then an important intermediate step is you query that learner that you've just created. So you use your training data and you query it across all that training data. Now, there will be some data points in the training data for which this bagged learner uh, doesn't perform well. Um, so what you do is you keep track of the ones that it doesn't match well, and you emphasize those samples. In other words, you boost the probability of those samples that it performed poorly on according to how poorly they did. So when you build the next bag, you sample, but now it's not totally random. It's with weights according to the error for each sample. So you will more likely select samples that you perform poorly on in the first place. So now you have a learner with two bags, and you do exactly the same test again against those two bags to pick the third bag, and so on. So each bag in this boosted learner uh, is emphasizing the things it's doing most poorly on. For Ada Boost, what percentage of bad data do you carry over to the next bag? What's the cutoff to say it did not perform well? So the traditional way to handle that is you just um, measure the error for all of your sample points, and the probability of selecting that sample in the next bag is proportional to the error. So you normalize across all the errors, and the one with the largest error is going to have the highest probability. The one that's got the lowest error is going to have the lowest probability of being sampled in the next bag. There's really no cutoff. It's just a uh, a probability of it being selected for the next bag. For the bag method, does k change from 1 to n, where n is the number of bags for our models? No. Uh, k should be the same for all of your bags. You might separately run an experiment where you create a bagged learner with different k's, but for each k, all of the learners inside the bagged learner should have the same k. Which data to use for showing the overfitting and bagging section of rubric? So I would have to look at the, let's look at the assignment itself. Okay. Use bagging in conjunction with KNN with the Ripple dataset. How does performance vary as you change the number of bags? Okay, so that's the bagging part. I think we separately wanted, let me look at your question again. Which data to use for showing the overfitting and bagging section? Yeah, so you should use the Ripple dataset. That's what we're looking for. Okay, there's no new questions. Let me, I'll remain here for a little bit. Let me know if you've got anything in particular you want me to explain in more detail. Let me ask first, does everybody feel like they know how to implement KNN, or do you want me to sketch out a potential solution for you? And by that, I mean I would just draw something. I don't know what the delay is, but unfortunately, there's about a 20 or 30-second delay between what I say and before you hear it. So I'll just wait here for a few moments to see what you all want to be answered. Okay. Somebody says they want a sketch of KNN. Okay, I'll do that. Let me switch there. Okay. All right, so pardon the quality of the drawing while I do this, but okay. So here, let's consider our training data. We'll call it X train. And for this project, we've got X1 and X2 are the components of our training data. And this is a ND array. And each row here represents one sample. Now, of course, we have to have Y values that go along with that. So that's Y train. And that's just a single dimension, as we mentioned. Okay, now when we call add evidence for our KNN learner, all that we need to do for add evidence is to store this data away. You don't need to build any models or anything like that. You just save this data. The real meat of KNN is at query time. So let's suppose we're going to make a query. Now, one thing to keep in mind is that we usually pass in an array of queries. So we don't query just one point. We query across multiple points. So what we're asking, when this query comes in, is we're saying, for this value of x1 and this value of x2, what is y? And we want to know that not just for this first row, but for all these rows. Okay, now, There are ways that you can vectorize this and make it quicker, but for now, let's just think about it as a for loop. And let me show you what to do at each step of the for loop. And by the way, this is the return value. So remember, for query, you don't know y. You're trying to find y. All you know is these x points that you want to discover what the model predicts y will be. Okay, so we're going to do a for loop. All right, so my don't get on me about my Python syntax, but it'll be something like x test shape of 0, I think, something like that. Anyways, just how many rows of data we have. Okay, so we'll take the first one, and this is what we do with the first one. So we're going to query this single point. All right. First thing you need to do is calculate the distance. So I'm just adding a new single dimension array here, which represents the distance of each of these points from this particular point that we're looking at. So we're doing a for loop over each one of these. We're looking at the first one here first. Okay, distance. What's distance? It's Euclidean distance. It's x. Let's see. X train of I. Let's use j, different variable, minus x test. I'm screwing this up. Let's just look at let's just sketch out Euclidean distance. So it's the square root so it's x1 minus x1 query squared plus x1 minus, I'm sorry, x2 minus x2 query squared. And however many dimensions, you just take this difference. So it's the difference for this first one. Let me get another color. It's the difference between those two, this one and that one squared, plus the difference between that one squared. And then you take the square root of the whole thing. And that's Euclidean distance. It's easy enough just to calculate this yourself, write a simple equation to calculate it. There are also, I think SciPy has a distance method that you can pass this data to. But anyways, for this query point, you calculate its distance to all of our training X points. So you calculate that one, 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 right? Okay. So let's say this is 0.5 and this is 0.6. This is 1.0. This one's 2.0, 0.1, 0.2, and so on. Okay. So this represents the distance from each one of these points to the point that we're querying. Now, recall the name of this algorithm is k nearest neighbor, where for most of our experiments here, k is equal to, k is equal to 3, right? But k doesn't have to be 3. It can be any other, value that we like. But for now, let's just think about it as being 3. Okay, what we want to find is the 3 values here that are closest to the one that we're querying. One way to do that that's fairly easy is you sort. So you sort on this distance, and what'll happen is the smallest ones will be first and the largest ones will be last. Now, when you do this sort, you need to be sure that you keep track of the X rows and the Y rows so that you keep the relationship between them. Anyways, there's a number of different sort methods. I think I recommend using argsort, and what it returns is another list that for each row it tells you. Each element tells you which row is the first one and the second one, and so on. In any case, after the sorting, because k is equal to 3, we want to just get the 3 smallest ones. So those are going to be the ones that are closest to this query point. Then we take the y's associated with those, and we just take their mean, and that is the response to this query for that first element. Then we go to the next one, and the next one, and the next one, and the next one, and we put the values in our return array as we step through these, and then we just return that array when we're done, and that's the result of the query. So that's how to implement KNN. Okay, I'm going to go back and look at other questions we might have. Okay, well, there's lots of people are saying they would like KNN. Okay, so I think what I just drew is exactly done in the video lessons. In fact, I think I did it better when I recorded those video lessons. So let me advise you, if you had any confusion here, go back to Udacity and watch those video lessons. Okay, we got a few more questions here. When training, I'm able to match the values shared in Piazza via the results sharing thread for in-sample KNN. For out-of-sample, I get an error about the shapes of my, I'm assuming, ND arrays. Maybe I'm doing something so obviously wrong that it's obvious. So that's not enough information for me to know what to tell you. I think you need to, well, one thing you need to realize is that when we're training, we're going to have 60% of the data here. And so with the 1,000 samples, this one will be 600 long. But when we're querying, our test data is only 400. And so you need to be sure to correctly iterate through each of these rows. So the query is definitely a different dimension than the training. So you need to make sure you account for that properly. Okay. Does the 5-second requirement include the time for in-sample and out-of-sample evaluation? So 5 seconds is for training in-sample, and then testing either in-sample or out-of-sample. Anyways, it's just for a single training and query. It should actually be a lot faster than that. We're being actually kind of generous by allowing up to 5 seconds. Lots of people are getting a few milliseconds for their implementations. So if you are getting much more than that, you're an important speed up, by the way, is when you're calculating this distance, figure out how to vectorize that. My guess is that people are probably spending a lot of time in computing this distance doing for loops, and it's better to vectorize it. Okay, that's all the questions I see so far. I'll wait just a couple more moments to see if there's any other questions. Okay, no more questions. I hope you all found that useful, and I'll be also on Piazza ready to answer more questions if you have them there. Have a great evening, and thanks for your attention. Bye-bye.